Although nowadays manufacturing a PCB online is incredibly easy and affordable, being able to develop handmade prototypes at home still being a very good option for many projects. These are a couple of examples made using wire wrapping cable. This video shows how to design and build an affordable cable pillar. This cable pillar can strip a very short segment and also a very long one. The design is based on utility knife blades and the scales are made out of a custom-made PCB. The PCB design has been made in Eagle, but the design itself with the measurements and so on has been made in DraftSight, basically because it's a free tool capable of generating a DXF that later can be imported into Eagle. First of all, I draw the blades and put them in the position. Once the blades are finished, it's possible to draw the rest of the scales based on the design idea. With the DXF finished, now it's possible to start designing the PCB. The first thing to do is importing the DXF file. While importing, I specified that the DXF will be drawn in the 51 layer, one of the documentation layers. After placing all the lines in the drawing area, I will change the layer of the edge to the edge layer. There is a small gap that has to be finished. In general, in Eagle, the way to specify a precise position of a line is changing the properties XY location. So to snap to an existing line, it's necessary to copy the position of that line and paste it into the properties of the current line. After importing the DXF, several lines of the board edge weren't joined together. So it's necessary to do the same trick of positioning the begin and end of the lines at the same position, just copying the properties. And finally, the board is closed. Now placing the holes. The holes are 2.5 millimeters diameter. This makes possible taping the holes in one of the scale and drilling 3 millimeter holes in the other. Once again, to place the holes precisely, the better option is to copy the position properties to the already existing hole drawings from the DXF. The hole in the middle is just for hanging the pillar in a tool wall. Finally, it's only necessary to move the silk screen lines imported from the DXF file to the top silk layer and change the width to something printable, in this case 12 mils. In order to make it stronger, both top and bottom layers are covered with a copper pour or ground plane. The easiest way to do this is using the convert to polygon option that can be applied to the board edge. Later, this polygon can be converted to a signal plane. The last thing needed for being able to order this PCB is generating the Gerbers. The only information needed in this case is drills, top and bottom copper, the edge of the board and the top silk. In this occasion, I'm going to order the PCBs online at PCBWay. Before ordering, the best thing to do is quickly check the Gerbers with a Gerber viewer. In this case, I'm using GerbV because it's free, and then pack the files into a zip file. Once the boards have arrived, it's possible to start the assembly. The first step is tapping one of the scales. As the holes are 2.5 millimeters, tapping with an M3 tap drill is possible. The PCB material, FF4, is very soft compared to the tapping drill. This allows tapping very fast with a cordless drill. Just as a verification, the bolt that is going to be used later fits perfectly in the tapped holes. The second step consists of drilling bigger holes in the other scale. With this, the two scales can be bolted together with the M3 screws. The diameter of the holes is 3 mm, and the 2.5 mm of the scale serves as a guide, and it can be drilled perfectly with the same cordless drill. After marking the length of the blades, they can be cut with two pliers. Now that everything's ready, the cable stripper can be assembled. Finally, for adjusting the blades, I simply used a piece of paper.